So that's 1750. Everyone's cool with that, right? Says so right in the question. Sailboat goes up to Coal Island, which is over here. And then over to Fernie Island and then home, yeah? Right? It goes to Coal Island at a bearing of 16 degrees. North is 0. It went off at 16, so this in here is 16 degrees. Once you have one side and one angle, you can use trig to figure out the rest of it. So he sailed up there, so you needed the hypotenuse. So you had to do cos and 1750 right there. That got you the hypotenuse. There's the 1750, that's right there. And this, I use tan. Then you just add all that up. And I can't remember what the number is, but I'm going to do it right now. 1750, tan, 16. Plus 1750 divided by cos 16 plus 1750. 4,072. And don't worry, we'll be going over that this year again as well if you didn't know how to do it. This was the same thing except the bearing was 307. So, north is 0. What's east? 90. What's south? 180. What's west? 270. This guy went off at 307, so that was out there, yes? So if this is 270, this must be what? This must be 37 degrees, right? And if this part's 37, then what's this part inside the triangle? 53, because this whole thing is 90. So you had 53, 800, which I drew right here. And then you did O and H. Then you did how far the boat traveled. I cannot remember how far the boat traveled, but of course it is tan 53 equals O over A. So 800 tan 53, that gets you here. And then I'll change color and use purple for 800 divided by cos 53 to get the purple. And then you added 800 to get this side to get a total answer of 3190.9. And again, don't worry if you don't know how to read compasses. I'll be going over it again this year. That's the right answer there. You just had two triangles. You just had to work it out. You had to find this line first using that. And it would have been cos. And then once you had that line, you found the height using the blue and the pink, and that would have been tan. Microwave tower. Most of your problems with this question are usually in the drawing. If you read the question carefully, you say one anchor point is 9.8 meters from the base of the tower, and it goes up 37. There's another one from the same one that goes up to the top, and they want to know how tall the tower is. This one tells you how tall the tower is right here by doing tan 58 equals O over 9.8. So 9.8 tan 58. That gets you the height of the tower. Then you had to do this one by doing 9.8 tan 37. That got you this height. And then you needed to do this height by doing the pink line, by doing 9.8 tan 58 minus 9.8 tan 37. And that would have gotten you the green line right there. And I'm not going to bother. You can do the math. And this is what the suspension bridge looks like. The towers are 135 meters tall. The angles of the elevation are 10.8 and 18.65. So you had to do tan with this one. So you had to do tan 18.65 equaled 135 over y. So y equaled 135 divided by tan 18.65. And then you had to do the same thing over here, tan 10.8 equaled 135 over x. So 135 over tan 10.8 equaled x. That gave you x. Then you took that one and you added it with that one, and then you got your whole answer, and then of course you multiplied it by 2 because there's 2 towers. Now, and it ends up being 2,210. Now, there's a problem with that question, and it's put in here for a reason. What if you don't know what a suspension bridge looks like? Because a great many of you all know what a suspension bridge looks like. Once I draw it, the Port Mann is a suspension bridge. The Golden Ears is a suspension bridge. The Lions Gate is a suspension bridge. The Golden Gate is a suspension bridge. The Brooklyn Bridge is a suspension bridge. All these famous bridges, suspension bridges. But if you don't know what those are called, you just call them a bridge, you couldn't really do this question very well, could you? Right? And also, there are suspension bridges that don't have only 2 towers. For example, there's one in Greece that has 4 that I've driven over. It's different. So if you didn't know that, it makes it really hard to do the question. But it was also homework, and if you really cared, you could have just Googled what it looked like. Because if you Google it, you find many, many pictures of the Humber Estuary Bridge. Any questions? Everybody remembers Trig? Sokotoa Trig? Okay, then it is time to go on, cabbages. Turn to page, I don't know, 150. Angles in standard position. Okay. So up until now, what's the biggest angle that we have done trigonometry with? For most of you. If you were in Honors 10, you've gone a little further than this. But if you were in regular Math 10, what is the biggest angle you have done trig with? Pardon? Smaller than 180. 90. Every time you have ever done trig, you've had a 90-degree triangle, right? And you've done the same trig every time. You've either done sine, which is what? How do we find the sine of an angle? Opposite over hypotenuse. Or you've done cos, which is what? Adjacent over hypotenuse. Or you've done tan, which is what? Opposite over adjacent. Now, you guys are smart kids. You're aware that there's more than 90 degrees in our world, yes? the world deals in 360 degrees, right? So what we're going to do first is we're going to draw an angle that you guys know. You already know how to deal with it. Take your pen, pencil, whatever writing utensil you have, and draw a line somewhere out in the middle of the first quadrant. Now, is that an angle yet? No, because we've only drawn one line, right? How many lines do you need to make an angle? 2. They're called rays. So we're going to put the second one right out along here, along the x-axis. And these are both what we call rays, because they do not go forever like a line. They both started right there. Everybody cool? So these are both rays. And this, oh, I don't want to do it that way. I'm going to use a different color. This is the vertex, which is a fancy word for the corner of an angle. Is everybody cool with that? None of that should be news to you. You should know all those words. Everybody okay? Now, could we do trig with this line, this angle yet? No. What would I need before we could do trig right now at our level? I would need a third side of a triangle, wouldn't I? And where could I put it? I could connect the two rays. And what angle would this make? 90 degrees. Now I could do trig there, couldn't I? Right? This would be our hypotenuse. This would be our theta. What would this be? Opposite or adjacent? Opposite, because our theta is down here. And that makes this what? Adjacent. And then we could do all kinds of trig there, couldn't we? Now, if the big Cartesian coordinates thing wasn't there, and I only drew that triangle, we could do a ton of trig with it, couldn't we? The only difference now is we've got this thing here. Is everybody cool? And once we have this thing here, that means we have to be aware of a couple of things. Like, what do you call this line? That's the x-axis. And the x-axis is split into what? Four? Just the axis. The axis is split into two. What? No. Just the axis is split into what, Luke? Negatives and positives. Negatives and positives, right? And we also have the y-axis, which is split into what? Same thing. Positives up there and negatives down there. And as Sonia said, she's just one step ahead of the question I'm asking. The whole thing is divided into 4 quadrants, right? We're going to come back to quadrants later, but right now, that is what I want you guys to see. I need you to be aware that there's positives and negatives, both up and down, and left and right. Everybody cool? So, we know this is adjacent, but now we have to be aware of one more thing. Not only is it the adjacent side, it's also a positive value. Everybody cool? And what is this? Not only is it the opposite side, it is also what? A positive value. Is everybody cool? All right, now you can see there's a crap ton of vocab here. Do you guys have blanks or do you have it all written? I can't remember what I did for you guys. You have this? Okay, then get out some way of highlighting. Because I'm going to highlight the words that you need to know. Everybody ready? Okay, standard position. I'm going to use that term all the time. Standard position is the vertex is at the origin and the initial ray lies on the positive x-axis. I'm going to do some highlighting now. Initial ray, I'm going to underline in blue. And I'm going to leave that line blue, because that's what the initial ray is. If it starts from 0 and goes positive. Everybody cool? Lies on the positive x-axis. Everybody good? The other ray, and I'm going to change colors here to pink. The other ray is called the terminal arm. That's this one. And since it goes from here out, that whole angle is in standard position. Is everybody cool with that? I'm just getting to that, Luke. Great question. Notice that this line has to stay here, right? But I could put a pink line out there, couldn't I? Is it still standard position? The first line, the first ray is where it stayed. The pink one is the one that moved, the terminal moved. Is that still standard position? Yeah, so even though we've gone over here to a negative, we're still in standard position. I could put it down here, right? And then I'm still in standard position. Or I could put it down here and I'm still in standard position. Is everybody cool? Doesn't matter where the second line goes, as long as the first ray stays there, we've got standard position. Now here's where it gets a little bit weird. We all know how to measure that angle, right? Goes up to 90. And then we can go all the way around to here and it goes up to 180, right? So we know this angle here is something between 0 and 180. But then we get into trouble. How do you think we measure this angle, this purple one? What must that be? $90, 180. What must that be? Bigger or smaller than 180? Bigger. Everybody cool? And then I can go one further. The orange line. Now I'm going all the way around here. 90, 180, 270. What must that be? Bigger than 270. Everybody cool? Now, the only other thing you got to be aware of is this. If we go counterclockwise, or if you're from Britain, anti-clockwise, then we have positive angles. Where do you think we start counting from? From 0. Where's 0? Up top or the x-axis? X-axis, because the x-axis is our initial arm. Everybody good? So if I go this way from the x-axis, I have what's called a positive angle. So this pink angle right here would be positive because I started here going this way. What if I start here going downwards? Then it's negative. Counterclockwise is a negative angle. That way is negative. So this pink line here, actually every line technically has two values, doesn't it? If I go this way, it's positive. If I go this way, it's negative. Is everybody cool with that? It just depends on where you start counting from. Now, that's a lot to absorb all at once. So if you notice at the bottom of this page, I've broken it down slightly. Let's actually practice it a little bit. Sketch this angle. Okay? Now remember, when I say sketch, what am I looking for? Am I looking for you to break out a protractor and draw it exactly? No. What do you think the point of this section is? It's to get you to understand where the angles go. Okay? So let's start with this very first one. Is that a positive or a negative number? Positive. And since it's in standard position, where must the first line always be? 0 on the x-axis. So every one of these starts here. Is everybody with me? And since they're positive, what direction do we go from the x-axis? Clockwise or counterclockwise? Counterclockwise, which is this way, correct? Now, if I need to only go up to 30, where would that be approximately? This is 90, so 30 would be about a third of it. Is everybody cool? Everybody good? Yeah? Okay. You guys do A, B, and C. Where would 135 be? You can talk to your neighbor. This is not a test. And it's also something that you have probably never had to think about until 5 minutes ago. So do not feel bad about checking with your neighbor and guessing. So, would anybody like to volunteer where they put B? If you need reminding, this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. Where did your terminal arm in B go? Luke? Third one? Second one, there you go. Because 135, this is 90. This is 180, so 135 had to be in the middle. Cool? Everybody good? Okay, where does 245 go? Which quadrant? Which one, Megan? The third one. It's going to go down here. Because this is 180 and this is 270. Is everybody cool? Okay, where's 65? Now that you've practiced 3, you should just be able to draw these like without even thinking about it. Where's this guy? Sarat. First quadrant, right there, right? Where's this guy, Max? Fourth quadrant, right there. Excellent. Where's this guy? Who haven't I picked on? Burke, where's this guy? Second. Is everybody cool with the easy ones? Okay, now you notice I've drawn 2 more here to mess with your heads. Where would negative 65 be? Quadrant 4, and I'd go down here, 65. Cool? Where would 405 be? Quadrant 1. I go all the way around to 360, and then I go another 45. And here I am at 405. Is everybody cool? Yeah? Everybody understands terminal arm and initial arm and how to draw an angle? Because it seems easy now, but it's going to build really, really fast. You need to be good at this. Everybody okay? All right. Let's turn the page over. Now, you guys are smart kids. We need to talk about a new thing, and I'm highlighting it so it's important. Reference angle. Now, this is very easy concept, but it's hard to do when you draw it. So we're going to start with defining it in words first. If you have an angle in standard position, which we just drew 6 of, right? The reference angle is the angle between the terminal arm and the x-axis. Okay? Everyone can read that, right? Everybody knows which is the terminal, which is the initial. We're good? Okay. I'm going to keep with blue for my initial arm. So everybody draw their initial arm. I'm drawing it in blue. You don't need to draw it in different colors because you know it goes along the x-axis, right? Now, everybody draw me a terminal arm at 120 degrees. Where would that be? Has everyone drawn it? Okay. Hopefully you drew it all, and I'll keep my terminal arms pink. Hopefully you drew it all out there. Somewhere. We're not going to get it exact because we're just sketching, right? Everybody cool? Okay. This is our standard position angle, right? And that is the 120 degrees. Agreed? But you guys are smart kids. You notice, hey, wait a minute, doesn't that make another angle out here from my terminal arm and the rest of the x-axis? How big is this? Why? This is 180. I've used up 120 of it, so this in here is 60 degrees. Is everybody cool? And that is what we call our reference angle, which is why I'm highlighting it in yellow like I highlighted the name. Is everybody good? Okay, so I'm going to draw 2 more standard angles. You guys are going to tell me the reference angle. Everybody cool? All right. So the first one is going to look like this. You tell me the reference angle. Then I'm going to draw another one while you're thinking of that. I'm going to wait a moment while you think about it. Remember, the reference angle is between the terminal arm, which in this case is pink, and the x-axis. Would anybody like to risk telling me where this guy's reference angle is? And its value, Sukhpal. Its value is 75 degrees. How did you come to that number?
180 plus 90 and then minus 195.
Okay, so you did 180 plus 90 minus 95? 195. All right. I like that you're doing some subtraction, and I like you know that 195 is part of it, but you're not quite right. Max? 15. Why?
Because 195 degrees is 15 away from the x-axis.
How far is that?
180.
We went 195. So what's left in here? 15 degrees. Because I have to be between the pink line and the x-axis. Is everybody cool? That makes this guy the reference angle. Sophie. No, the nearest x-axis. Everybody cool? So what's this guy? $55. And I guess I'm going to actually change this because apparently I should have said this. And the nearest x-axis. Is that better? Okay. Everybody cool? Everybody cool? All right, now I'm going to draw the only one that is kind of weird. What is the reference angle here? What is it, Sukbal? 32. Because the angle between the terminal arm and the closest x-axis is the same as the initial standard angle. Is everybody cool? Everybody can tell me where the reference angle, where the standard angle is, and how to find them, right? Okay, well, let's see. I've asked you to draw 4 of them there. Go. Draw both the standard and the reference. I've got my pink ink ready to go, and I'll wait for you guys to tell me where to draw them. And as always, I will wait a moment and then ask for volunteers. Is that enough time? I don't want to rush you guys. I really do not, because this builds, it goes from I get this perfectly to eep very quickly. It's like walking out at the beach and you get to that spot where it drops off. Your aces, you're fine. Then you take one more step and all of a sudden you're in 40 feet of water. It's just like that. So I do not want to rush you. We have all week with this. We're not going to get into any crazy stuff before Christmas, because the crazy stuff is hard to do if you don't get this stuff. Is everyone good? All right. Would anyone like to tell me where to put my pink line? I'm only going to draw the pink one. I don't need to draw the blue one anymore, do I? Along the x-axis? Okay, so where do I put the pink line in A? First quadrant, right there, right? And that's way bigger than 15, but I want it to be big enough for you guys to see it, right? So the standard is 15. I'll draw the standard in black. And what's the reference, which I'll do in gray? 15 again. Nice job. Everybody good? All right. New person to volunteer where 120 is going. It's pretty easy. We've already done this one. Where is it? Second quadrant. Where's the 120, which I draw in black? Right or left of the pink? Right. Here is the 120. Because I go there. Yeah? What's the reference angle? 60. Because I go there. Right? And I find it by doing 180 minus 120. Cool? All right. Where's 250 going? Third quadrant, down here. Where's the 250? Above or below the pink one now? Above. It's coming around here, yes? There's the 250. What's the reference angle? 70. It's in there. And how do I find it? 250 minus 180. Because I've used up that whole 180 right there. Okay, everybody cool? Okay, and the last one, where's 350? Quadrant 4. The 350 comes all the way around to there. What's the reference angle? How much? 10. And how do I find it? 360 minus 350. Is everybody cool with just using angles? Yeah? Now you will notice that all of these terminal arms have no measurement, do they? Like, we can't do any trig here because you don't know how long that pink arm is, do you? Right? But now, look what I've asked you to do. Where is 3, 2 on this? Because now we're not just thinking of 360 degrees, we're also thinking of x and y axes. So where would 3, 2 be? In the first quadrant, where would I go? Right 3, 1, 2, 3, and up 1, 2. Everyone agree? 3, 2. Now all of a sudden, I have my pink line right there, right? Now, how far is this? 3. And how far is this? 2. Now I could consider doing some work with this, can't I? Okay, where would this guy be? -5, -1, right? So now, what is this distance? -5, because I went to the left. And what's this distance? -1. Is everybody cool? Do the next 4. 6. I can't count today. And make them look like A and B. Can everybody do that? Everyone in the room understands to here. Yes? All right. I'm stopping with new stuff there, and I'm asking you to do page 152. You can write right on the sheet.